Hello everybody, welcome to Dr.K.Liu Maths channel. This question is from CU HK. CU's I think it is exam question or some public quiz or public exam questions. I cannot sure. And this question I sort the first two parts for you, and that is the proof for consider for any integer n greater than or equal to 2 proof for the following identity. Combinatorial proof. Combinatorial means by using the method of counting. Right hand side using method of counting. Left hand side, right hand side and left hand side also using counting. And for the part B, we have to use algebraic method. Algebraic method which included by deduce this identity step by step to this one. Okay, before the start of this question, I first show you an important things, that is binomial theory. 1 plus n equal to summation NCR. Oh, sorry, I use k equal to 0 to n xk. If we put x equal to 1, then the left hand side this is equal to 2 the power n. The right hand side is equal to summation k from 0 to n nck. And if we replace n by n minus 1, then we have summation n minus 1k summation k from 0 to n minus 1. Then we have 2 to the power n minus 1. Okay, now let's go to the detail of this, the first part. Using the combinatorial proof to prove this summation. This is NCK. NCK has several notations, which includes this one, and this one. Usually, I think everybody will know that. Okay, for the right hand side first, let's look at how I choose. If there are n objects, 1, 2, 3 to n objects, I choose the method is like that. I first choose one object. Choose one from this n objects. Then the number of permutation, number of combination is equal to n. Then once I choose one, then there is n minus 1 objects left. Then for this n minus 1 objects, I choose n minus 1, I choose 1 and 0, and n minus 1 choose 1, and n minus 1 choose 2, and then n minus 1 choose n minus 1. Then n times this, the sum of this one is actually equal to this one. It is 2 to the power n minus 1. Then it is the right hand side of this one. And for the left hand side, I also for the object for the left hand side, and there's n objects, 1, 2, 3, and n objects. In this case, I choose the method is like that. I choose 0. I choose 0 object, and then I divide it into 1 is 0, 1 is n, then n minus 1. And that left the one part is 0 object, the other is 1 to n. Then from this one I choose 1 object. This is first choosing method. And then next I choose one object from n. That's n01. Then the other is choose the other object, n minus 1 object, is I choose 1 object too. And then plus I choose n, choose 2. The other is n minus 1, choose 1. Choose 1 object. Yeah. And then n minus 2, not n minus 1. And then, or choose 3 objects. And the left n minus 3 object, choose 1 object. And then sum to all the case. And the last one is n, choose n minus 1, and that's 1C1. Actually, you can see that this method of choosing object is actually same as this one. And simplify this. For I simplify, that's NC1, the first one, because N0 is 1, NC1 is 1 plus this is let me see, NC1 is N, oh sorry, NC0 N plus NC1 N minus 1. That's third term is NC2 N minus 2. And then the last one is NCN minus 1. 1C1 is equal to 1. Yeah. And has NC0 is equal to NCN. NC1 is equal to NCN minus 1. This is NCN minus 2. And then the last one is NC1 times 1. Using the summation form to express this expression, that's NCK times K. That is actually right hand side of this one. That is the second method of choosing. Therefore, we can conclude that summation k from 1 to n, NCK k equal to 2 to the power k minus 1, n minus 1. Yeah. Okay, for part B. Given an algebraic method to prove this one, and very easy this one. I just give you one for this. Consider 1 plus x to the power n, which is equal summation from k from 0 to n, nck x to the power k, and then differentiate this one. Differentiate 1 with respect to x. Then the right hand side is n times 1 plus x to the power n minus 1. The left hand side is this one. The right hand side is summation k from 0. Because the 0 part is constant, then we can start from 1, k from 1 to n. nck times x, k times xk minus 1. And then put x equal to 1. The left hand side is n times 2 to the power n minus 1. The left hand side is summation k from 1 to n, nck k. That is the identity of the above expression. Okay, here of course I don't want to use mathematical induction. In my Chinese version, I also present this method, but I think in this version I only present one method and never use his hints. Okay, I hope guys can enjoy this video. If you found Dr.K.Liu Maths channel is useful, please subscribe my channel. Bye bye.